this is your cover page. If you open up the cover page, you should see these two examples of your isosceles and equilateral triangles. So we're going to just add some basic knowledge or facts that you need to know. Okay, so isosceles triangle. What is an isosceles triangle? Most of y'all know it as one thing. What is it? Yeah, it's a triangle that has two congruent sides. Okay. It's not just going to have two congruent sides. It's going to have two congruent sides and two congruent angles. All right. So if we're talking about the two congruent sides, then on a diagram, like of a picture of an isosceles triangle, we should see tick marks to indicate that. Okay, so we're just going to put the tick marks on the two sides that would be congruent. To indicate the two congruent angles, that would indicate arcs. So the arcs would go at the bottom of the triangle. And there's parts of that. That's called the base angles. At the bottom is the base. Now, an equilateral triangle. What defines an equilateral triangle? Yeah. Three congruent sides, all sides congruent. Okay. So we need to see three congruent sides. Therefore, I'm just going to do the symbol for therefore. There's three dots that form a triangle. You have three congruent angles. Okay. So tick mark, the same tick mark all the way around, and then arcs to show three congruent angles. If it's equilateral, then it's equiangular. And then because the three angles are congruent, what would be the measure of each angle? That's always going to happen with the equilateral. Yeah, we just take the 180, divide by 3. Each angle would have to be 60. Okay. Now, the vocabulary, the parts to an isosceles triangle. So besides these two examples here, we have a triangle here that we're going to label. That's going to be indicating our isosceles triangle, the vocab. All right, so the main parts. If we see the two tick marks here, right, that's indicating right here, this is what we call the legs of the triangle, of the isosceles triangle. The legs, I said, sit up, please. Your legs are basically the two congruent sides. The legs form, they meet up here at the top, and this is called the vertex angle. Okay, where the legs meet, they form the angle, which we call the vertex angle. So the vertex angle is formed by the legs, and then across from the vertex angle, so like if I look across down here, this is what we call the base of the isosceles triangle. And then, I don't know if y'all see here, but this would be our base angles. Your base angles are adjacent to the base, and they are also going to be congruent. That's why they're putting the arcs to show you that they're congruent. Another fact you're going to use, which is part of the theorem, is that opposite your legs are the base angles. So if I look opposite my tick mark, that would be, let me change my font here. That would be our base, where the base is located, okay? All right, so our first part, the first theorem relationship we're going to use, if you look at the tab that says base angle theorem and its converse. Okay, so we go to the next page right here, the base angle theorem. All right, so it breaks down like this. It says if we have two sides of a triangle congruent, then the angles opposite them are congruent. So if I see two angles congruent, then, I'm sorry, I said angles, I meant sides. That's the converse. So if I have two sides congruent, then opposite the sides. I can write today. Opposite the sides angles are congruent. Because we're going to do the converse of this relationship. So the converse is just the thing we learned at the very beginning, our different types of conditionals, is where if I know that this is true and I switch it around and it's true, then it will work as well. So I can work forward or backwards. So in order to use this theorem, we have to see two congruent sides. So on number one in this example, because they want us to find x and y, by seeing these two tick marks right here, I'm showing two congruent sides. So now what they're saying is if I use the theorem, if I look opposite those sides, so if I look just across, I'm just pointing across, that would indicate this angle here is opposite, and I look across. These angles opposite those two congruent sides are going to be congruent. So because I have those two tick marks, then I can conclude those angles are going to be congruent using the base angle theorem. So that means that my equation would be 7x plus 2 is equal to the 8x minus 7. Now we're just going to solve for x. Just start with the smallest variable. So minus the 7x on both sides. That will cancel, giving you 2 equals x minus 7. And then you would just need to add 7 to both sides, and we get our value for x. 9 is our x. Now that we have that value, to get to the y, we have to plug it back in. So this is basically saying 7 times 9 plus 2. That turns into 65. So this is 65, and since they're congruent, this will be also 65. So every triangle has a sum of 180. If these two base angles are 65, to get to my angle y, what would be this vertex angle measure? Yeah, because 65 and 65 is 130, so this would be 50. So to find my value of y, I'm just saying 2y equals 50, which means y equals 25. Take half of it. So, number 2, same relationship. They give us the tick marks. So now that I see I have two congruent sides, I have two congruent base angles. What's the equation we would start here to solve for x?
2x plus 4, 4x minus 22.
Yep, 2x plus 4 equals 4x minus 22. Good. So same thing, we want to solve for x. Okay. So start with our smallest variable to isolate. So minus 2x gives me 4. equals 2x minus 22. Then add the 22. So 26 equals 2x, which means x is what? 13. All right, so now find the y. Okay, I want you to see if you can get to the y. You got to plug it back in, get those angle measurements, and then get your vertex angle and solve for y. So it doesn't matter which one you plug it in. Like I would probably do this one. This one to me is the easier one. 2 times 13 plus 4. If I double 13, that's 26 plus 4. That makes it 30. So now I know both angles here are 30 and 30. So what is the vertex angle?
30.
No, that's the y. 120 is the vertex angle. Yeah. Okay. So up here is one. Yeah, and y equals 30. Exactly. Your y should equal 30. Are we okay on that? All right. So basically, if I have the base angle theorem for an isosceles triangle, the converse of the base angle theorem, anytime I'm dealing with the converse, this is basically when I just switch the order. Okay, so I'm just switching the order of the original theorem. So now I'm saying if I switch what you had up here we were talking about sides, then angles. If I switch this around, okay, now I'm going to talk about the angles and conclude the sides. That's all we're doing, is doing the converse of this. So if you see right here, it says if two angles of a triangle are congruent, then the sides opposite them, are congruent. So they're going to start off with the angles. So you're starting off with the arcs. So here it's given that you have two congruent angles based on those arcs. Then, because I have those two congruent angles, if I look opposite those angles, those sides are going to be congruent. So if I'm given the two congruent angles, then opposite sides, and I ran out of room here, are also going to be congruent. So here, my equation would be 5x plus 7 equals 42. And we're just solving for x. So isolate the 5x by subtracting 7. 5x equals 35. Divide by 5, so our x equals 7. Okay? Alright, I want you to try number 4, using the converse of the base angle theorem. So I know it kind of looks not to scale, or the orientation is crazy, but start with your arcs and then look opposite. Let's see if you can write the equation, then solve for x. Okay? And then we're going to talk about the homework that's due today before you leave. Did you get 4? X equals 4?
Yep.
All right, we're good. Okay, we're gonna just stop right there, and we're gonna go to the next page. But I wanted to address, because I told you I was gonna give you some more class time on some previous assignments. So